This is an introduction to Solidity Programming and Blockchain Technology presented by Coding Boot Camps. We're going to start off with an introduction to blockchain technology. About our instructor, Jim Sullivan is a senior blockchain instructor and developer at DC Webmakers. As a software engineer with about 18 years of experience, Jim leads an expert team in blockchain development, DevOps, cloud application development, and the safe, agile methodology. Jim is an expert in blockchain platforms like Hyperledger, Ethereum, and Corda. Taking the courses below are highly recommended. So an intro to blockchain technology, JavaScript would be helpful, and learning Node.js, Express.js, or MongoDB. So an introduction to blockchain. So most people likely heard of blockchain when Bitcoin made its incredible price run around the year 2017. However, Bitcoin and blockchain are not the same thing. A blockchain can run without Bitcoin, but Bitcoin needs to run on a blockchain. Blockchain technology extends beyond Bitcoin, and blockchain is the underlying technology that secures and verifies Bitcoin transactions and other transactions. Blockchain is essentially the foundation for the Internet of Value. And we'll talk more about that. Bitcoin is a digital currency. It's open source, anonymous, and transparent. Bitcoin was founded in 2009 by Satoshi Nakamoto. This is a pseudonym, so nobody knows the true identity of Satoshi Nakamoto. If you want to get more information about Bitcoin, there is bitcoin.info, and there's also several, this is one, but there are several Bitcoin and blockchain explorers that you can use to get more information. Bitcoin is the largest cryptocurrency, and again, bitcoin.org is its website. So that is the community. This is the actual Bitcoin community, and Bitcoin itself is a community. What gives Bitcoins their values? The exact same thing that gives gold, silver, or dollars their value. It's the demand for them. And if we think about it, gold, silver, diamonds are not liquid either. They must be exchanged for cash or some other medium of exchange to purchase goods and services. So Bitcoin first appeared shortly after a white paper by Satoshi Nakamoto was made public. This is a relatively small or short, I guess you could say, short white paper. You can look it up, and it is right on the bitcoin.org site. It's about 10 pages long. Again, Bitcoin is an application that runs on a blockchain. Likewise, just similar to the way that Instagram is an application that runs on the internet. You can make that comparison. Blockchain is secure peer-to-peer or person-to-person transaction system for transacting, in this case, in a blockchain case, it's transacting either some kind of digital token or digital currency or other items of value. It does not have to be a Bitcoin or a digital currency. For example, transactions can be as simple as using your smartphone and sending funds to another person. Blockchain runs in a truthless environment that allows transactions to be completed without a third party to provide trust. So again, blockchain runs in a trustless environment where the transaction is completed on the blockchain and is confirmed immediately. So all parties know that that transaction was confirmed. Just a quick look here at blockchains at scale. So blockchains would use the internet in the same way the World Wide Web uses the internet. So like we said before, that the internet is the host for an Instagram. So Instagram is part of the World Wide Web, runs on the internet, and the blockchains would also run on the internet. And then on top of the blockchains would be applications like Bitcoin, Ethereum, other public blockchains. So blockchain's mix of cryptography, distribution, and transparency results in a very powerful, secure, and immutable type of technology. Its unique construction allows for countless number of users and makes transactions of all kinds simpler, cheaper, more secure. Cheaper transactions also pave the way for microtransactions. So in the developing world, uh, cryptocurrencies open the door to very, very small transactions, which by today within today's banking system would be too expensive because of fees. And blockchain is already being called the technology of the decade. It is the most significant technology advancement since the internet. And while said these statements may or may not be true, chances are you will be interacting with blockchain or it will affect your business in some way. So, well, blockchain is already creating new ways to solve old problems. So, transferring money, it can be transferred directly between individuals. Tracking of data and files. So, files can actually be uploaded to blocks, and those files then can be tracked transactionally. Automation of contract execution. So, just like with most contracts, there's some agreement and some obligations for the parties in the contract, and can blockchain can automate that process. And there's a long list of other uses for blockchain or other solutions for old problems. So blockchain is decentralized. So there is the it is actually a blockchain. You can think of it as an operating network. So it's a network of nodes. It's also an electronic ledger uh, used to record transactions of any asset or anything of value. Data entered into the blockchain is immutable and incorruptible. And we'll talk about why that is. We just said it's decentralized, so there are many, many copies of the same data that exists on computers throughout the world. It's highly secure, so the fact that we have these computers all over the world, if one node or one computer was attacked, it would just be one node in a network of hundreds of nodes, and the one attack node could then could could then be taken offline, and the network would continue and make adjustments for that node that went offline. Data logged according to community standards, and it's permissionless. Uh, there is a flavor of Bitcoin that is what we call permissioned, and that would be Hyperledger or Corda, private blockchains. So we can see here the introduction of blockchain. You want to send money from A to B. The transaction was broadcast. Miners add a transaction to form a block. The block is broadcast to every party on the network, and those in the network approve the transaction or validate it, and then the block can be added to the chain in an unmutable in an unmutable fashion. So think of a blockchain sometimes like a spreadsheet. So the cells on a spreadsheet are all of the transactions. This spreadsheet, if the same spreadsheet is on hundreds of computers and you have hundreds of caretakers, each with their own copy of the spreadsheet, they're continuously updating it. That would be a very secure approach. It would also be very, very difficult to make unauthorized changes because so many users or caretakers are in charge of the spreadsheet. So each cell is almost like a block in the blockchain. And so, what would happen if copies of the same spreadsheet existed on computers of several users? Each user performed some entries of their own, and they also received entries from other users. Well, things could get out of sync. So, just like if you could imagine you have a document that's supposed to be the same document, and there are several other users working in that document can get slightly out of sync. So we have to have ways to resynchronize, and that is the idea of consensus. So the consensus means that we've got to determine who has the version of the document that everybody agrees has the most up-to-date data, or I guess has the true data. So we use a consensus algorithm or consensus method. Proof of work is currently the most popular consensus method or consensus algorithm for blockchains. Proof of work started as a solution to prevent computers from sending spam. But proof of work can be expensive, so alternatives have been have been discussed and have actually been tried. There are two generations of blockchains. So there's blockchain 1.0, which is like a Bitcoin, and then there's blockchain 2.0. First generation blockchains and second generation blockchains. Bitcoin is a first generation blockchain, and it only manages its native coin. So the only application that runs on the Bitcoin blockchain is the Bitcoin application. Blockchain 2.0 provides tools that allow us to take action on the records that are kept. So we could actually write applications on second generation blockchains. And second generation blockchains can also manage any type of asset. So we can define what asset we want to manage, and parties can define what asset they want to manage. Smart contracts are the programs that run on second generation blockchains to take action on records. The distributed ledgers that run on the computers, that run on the hosts on the computers, they're called nodes. So on every blockchain, this is true. Nodes contain a full copy of the blockchain. And this is true for most public blockchains. However, there are blockchains that are architected differently, where not all nodes are the same. So on a network like Bitcoin or Ethereum, every node is the same. There's just one type of node. On a network such as Corda or Hyperledger, there are specializing nodes. So not every node is different. Not every node is the same. In blockchain, the distributed users are called miners, so they keep the network organized and up to date. Miners maintain the blockchain, and miners update pending transactions on their individual nodes. Once verified by the other miners on the network, transactions are relayed to the other nodes, and the miners that confirm the transactions are paid a reward. In most cases, this is how cryptocurrencies are minted. The miners actually create, say, Bitcoin by confirming Bitcoin transactions. And once verified, the transactions become a permanent part of the blockchain. These are good blockchain videos. We're not going to go into them now, but when you get a chance, please take a look here and please enter these URLs. They do a good job explaining blockchain. Bitcoin is considered the first blockchain, and most experts agree with that. No user ever takes physical possession of Bitcoins, so Bitcoins are not downloaded. Ownership of Bitcoins are tracked on the blockchain. If user X needs to pay user Y 2 Bitcoins, the Bitcoin blockchain is updated with the new Bitcoin ownership. So it's strictly a ledger. Just like if you pay something by check, no money ever changes hands. It's simply between the two banks and maybe the Federal Reserve Bank. Ledgers are updated. So the currency that the check is written on simply changes hands by updating the bank's ledgers. So user X owns those 2 Bitcoins, and then they are debited. So now X has 2 fewer Bitcoins, and Y now owns those Bitcoins, and his account are credited with those 2 additional Bitcoins. So Bitcoin, if we want to transact, and this is true for any kind of cryptocurrency or any kind of item of value on the blockchain, users need wallets, and wallets are run by or recognized by what we call a user's public key. Despite the name, the wallet does not hold the Bitcoin or any currency, The wallet actually holds the credentials that conduct the transaction. So we can see the address here or the public key. Now these are very long and difficult to manage. So quite often we can use a QR code. So QR stands for quick response, and this QR code can be scanned to avoid users from inputting these very long addresses. And again, the user's wallet address is the user's public key. So this would be the public key right here. All users on the blockchain know your public key or wallet address. So that's your ID on the blockchain, or your address. Just like somebody wants to send you a package, they have to know your address, and your address is generally public. However, you also have a private key, and that is hidden. Your private key decrypts the transactions. So your public key and private key are related to one another. If we want to take a look at some blockchain transactions, we can go to a blockchain explorer. So for public blockchains like Bitcoin or Ethereum, there are several blockchain explorers, and we can take a quick look right now at some of them. Here's two of them. Here is blockchain.com, and we can see here we're exploring blockchain transactions. Let's refresh this so we can see the latest block, 631,088, and we can go to a different bitcoin.com, and we can see here, I'll just refresh it, but it looks like the same block, 631,088, and we can see it was mined by btc.top. Okay, same thing over here. So that's what we would expect. We would like to see, and we would expect to see, in two different blockchain explorers, we would see the same data. So let's take a quick look here. Let's go into, and right here is the current block. You can see it's 631,088, and we can actually see the transactions. Transactions are quite anonymous. And we can see here that this address, whoever this is, we don't know who this is, provided the inputs of this amount of Bitcoin. BTC is Bitcoin. And we can see the outputs of the transaction here. And if you like watching Bitcoin transactions and other blockchain transactions, you can certainly navigate in to your blockchain explorer, and you can watch them for as long as you want. So we can see here that this is a screenshot from a blockchain explorer. And again, we can see it's anonymous. You can see the input address and the output address, and we can see the amount and other transaction information. We never see anybody's name, address, account numbers, or anything like that here. So again, if you say we wanted, again, to use a credit card to buy, say, a candy bar, again, no money ever changes hands. It's strictly just the parties update ledgers and the bank updates ledgers. But this is not free. So there's a lot of ledger updating here, and there are fees. So somebody is paying a fee somewhere as these transactions are being approved. And again, you can navigate to one of many blockchain explorers. We just looked at one here, blockchain.com/explorer. Make sure you click on BTC, but you can see other blockchains on there as well, and then see the currently confirmed transactions. And again, we can see here this transaction, again, quite anonymous, and we can see some details on it. And this happens to be Bitcoin here. So in this module, we looked at the inspiration of Bitcoin. We had some introductions to some blockchains, and we looked at some blockchain transactions. So this is an assessment. So blockchains are maintained and organized on nodes called miners, true or false. Right? Sometimes we think of the miners as people and the nodes as computers. They could be one and the same. True or false, blockchain and Bitcoin are the same thing. True or false, the blockchain ledger is only available to the administrator. And true or false, blockchains can only manage Bitcoin. And for additional resources, please, this is some other information. And here is also some other information. And also for more training, blockchain management with Hyperledger is available. Hyperledger Fabric and Composer for developers. Introduction to cybersecurity with blockchain. Introduction to Ethereum development. Learn blockchain development with Corda. And Intro to Hyperledger Sawtooth for system administrators. And our next lesson is going to deal with the impact of, well, in this case, ledgers on society. Thank you.